If we want to give an LLM additional knowledge, generally speaking, we have two different options. It's either the in-context learning or, of course, the RAG technology. These are, at least in my experience, the best ways. Of course, we can also do fine-tuning and a lot of other things, but you already know that we can do this RAG technology. And in order to understand the RAG technology, we need to understand embeddings and vector databases. Because we can simply browse a PDF if we upload it, and we can search every single thing out of this file. In AI Agent, the RAG technology would look something like this. We have basically a vector database included. But let's just take this slowly. Let's come back into ChatGPT so that you can see how we can upload knowledge. And this can be everything. It can be a PDF, it can be text, it can be markdown, and so on. But generally speaking, the better you structure your input, the better the answers get. Normal PDFs are most likely messy, but let's just start with the basics. So let's just see this in ChatGPT. Of course, you can give context in the prompt, but let's just say you want to give a lot of context. Sooner or later, the context window will be reached. If you want to upload like a gazillion PDFs in this context window, the token limit will be reached. I hope you remember what the context window is. As soon as you have too much tokens inside your context window, the LLM will no longer understand what you are talking about. And of course, you have a few options to do this better. One of the best options is, of course, the RAG technology. If you go in ChatGPT, for example, of course, on My GPTs, you press create, and then you can use this knowledge here, and here works the RAG technology. If you upload files, something cool happens. And these files, they get stored in a vector database. Before they get stored, the embeddings model make them into vectors. And then we can do a search query. And the LLM will simply search your PDF. And now I want to show you exactly how this works. And then, of course, also how you can make this yourself with every single LLM, so also with open source LLMs. This article from NVIDIA, what is Retrieval Augmented Generation, aka RAG? This is a cool article. It's, at least in my mind, a bit too long, but I think this picture is perfect. Generally speaking, this is how it works. First of all, of course, we have a lot of PDFs, a lot of documents, a lot of whatever. And we want to upload our documents in a vector database. And of course, we need to do something so that this is working. We need to use the embeddings models to embed them in our vector database, and then the user can go on and ask something, and if it makes sense, the user query will get sent to the vector database. So simply the LLM browses our documents and gives us the right answer. And now I want to show you why this is working. First, I want to go in Paint. Let's just say these right here is the vector database. I make them simply as one big thing right here. Normally a vector database is three-dimensional. I will show you this later. Then we have, of course, the embedding models. So here we have some kind of an LLM, and then we start, of course, with our PDF. So in our PDF is data, of course. Then our data will get sent to the embeddings models. The embeddings models makes these embeddings. These embeddings, they are just like tokens. These are basically numbers, for example, 0.2 or 1.2 or whatever. This embeddings model, they simply make vectors so that they make sense. And these vectors, they get stored in a three-dimensional space. Let's just assume that we have here one cluster of words that are, for example, between 0.2 and 0.4. And here we have, for example, a cluster of words that is between 1 and 2. And now I want to show you why all of this is important. So basically we use our PDF, and the embeddings models, they make these vectors out of these. So they make these numbers. And if you Google vector database, you also get a rough idea how this works. So this vector database is then, of course, three-dimensional. And you know, of course, we get these numbers out. And these numbers, they simply make sense out of these words. So for example, the word apple will be a similar word than banana, and these embeddings, they get these. And the other embeddings, for example, wolf, dog, cat, they have other embeddings. And this is really important to understand. So basically, things that have a value of 0.2, this could be, for example, right now a cat. And this right here, this 1.2, this could be, for example, a dog. And if we come right now and we make a query, we ask something to the LLM will browse this vector database and will search in the right thing. If I ask, for example, something about bananas, the LLM will simply search the vectors that are in the banana space. If I ask something about a monkey, the LLM will simply search in the vectors where he finds all these animals. It's really that simple. Also, here is a cool example. Basically, the content gets, of course, in the embeddings model. Then the embeddings model, they make these vectors. These vectors have different numbers and they make clusters. And then, of course, these clusters get stored in a vector database and they get stored so that it makes sense for the LLM. And then if we ask, for example, a query, the LLM will go and search in the vector database in the right space what you want to get back. Let's just make an example right here once again. And now we do it completely different. Let's just assume that in this vector database there's a party. And at this party here is the bar. And here, for example, is the dance floor. And let's just assume that a lot of people come to this party. So on the bar there are, of course, the guys that drink all the time some beer. So here, of course, there are some guys and they have fun, they drink beer all night. So this is one cluster of embeddings. Then the second cluster on the dance floor, let's just say here are all the girls that have a little bit more fun than the guys that are just drunk. So here are, for example, the girls that have some fun. And where we are at this party, of course, we are not where the girls are, we are also not where the cool guys are. We are this cluster here, for example, and here are the AI nerds. So the AI nerds, they are here, they don't have fun, they watch a course. Makes sense. Of course, the AI nerds, they have also no muscle, they have no beer, they have no girls. Just like it should be. And now we assume that we are a dad or a mom from one of these girls. Of course, if we go into the party, we know immediately where we need to search her. We will most likely don't go to the drunk guys. We will definitely not go to the AI nerds, but we will go most likely to the dance floor, and me as a dad, I will spot my daughter immediately at the dance floor, because I know she is there. And that's basically how these embeddings in these vector databases work. The embeddings model, so this thing right here, let's just call it embeddings, this make clusters out of these words. Let's just say in this PDF there are some fruits and then some animals and so on. And these embeddings models, they will make these vectors. These vector embeddings, they get stored in the right place in the vector database, and as soon as we as the user ask a query, the LLM will know exactly where to search. Just like you as a dad or as a mom would search for your daughter at the dance floor and not where all the AI nerds are standing on this party. I think this should make sense. And this is why we can upload a lot of PDFs, because in the vector database there is a lot of space, and these embeddings, they are stored in one small portion, and if the LLM needs to search something, the LLM can search in the right spot. So if the LLM searches, for example, about bananas, it will search at the bananas embeddings, at the fruit embeddings. Just like we would search our drunk son right here at the bar, and if we have a doctor that likes to dance, we will search her most likely at the dance floor. So in this video you have learned, I think, a lot of things. You have learned what a vector database is, you have also learned what embeddings models are, and you have learned why the RAG technology is working. Generally speaking, we can upload some text. It could be a PDF, it could be a CSV, it could be whatever. Then the embeddings model will come and it will make tokens out of our PDF. These tokens, they will get stored as vector embeddings in our vector database. The vector database is three-dimensional and there's a lot of space. And we will make clusters with these tokens. So there's, for example, a clusters with fruits, a clusters with animals, a clusters, for example, with prices. If we have some prices, there are different clusters. And if we ask the LLM something, the LLM can then go search this vector database, search in the right spot, and will find the prices where the prices are, the fruits where the fruits are, and the animals where the animals are. Just like you as a dad or as a mom would search your drunk son at the bar, and if you have a doctor that likes to dance, you will search her at the dance floor. That's basically how all of this is working, and this is why this works so cool. So we have nothing in our context window. The LLM will simply search the vector database and gives us the right answer back. This is how we can give LLMs additional knowledge. This is the best and easiest way to give additional knowledge. Yes, we can do fine-tuning, but the RAG technology is much more efficient and is much faster, and I think you should understand this really clear. And of course, this is also perfect if you want to work with AI agents. Let's just say your CEO gets a task, and you can simply give one of these workers or every worker just like you want. You can give them additional knowledge with the RAG technology. So we would simply upload our PDF in a vector database with these embeddings models. And let's just say this is now stored in a vector database. And now if we ask the CEO something, the CEO will use the first worker. The first worker will browse its PDF and give us every single thing back. Let's just say that you are an expert in fitness, in bodybuilding, in dog training, in whatever. You can upload your knowledge, your specific knowledge, or let's just say you are in real estate, you can upload your real estate knowledge, and so one of your workers would have this additional knowledge and can immediately search this knowledge. As soon as this knowledge is searched, this worker will give this knowledge back to the CEO, and then the CEO can go on to the next worker. And let's just say the next worker would be, for example, a creative writer. So let's assume that we tell our CEO, hey, we want to have an article, a blog article about fitness. The CEO would go on and ask the first worker to browse its knowledge, our fitness knowledge that we have uploaded. Then the first worker would give this fitness knowledge back to the CEO. Then the CEO would give this task to the second worker. The second worker would be, for example, perfect for writing creative stories, for example, blog posts and so on. And then as soon as we have the blog post, this worker would give the blog post back once again to the CEO. And then the last worker, for example, could be a worker that makes tweets. Let's just say the CEO gives then also the blog article to the last worker, and this last worker would make tweets out of all of this and then save every single thing locally on our PC. He would have, for example, one tool that can save anything on our PC, and then we have everything. We have our specific knowledge with the RAG technology from our first worker, then the second worker would make our blog article, and that third worker would make our tweets and save every single thing on our local machine. And this is how we could eventually include the RAG technology in an AI agent. So we can come back one last time at this graphic. All of this can work with LangChain, but it can also work with different frameworks. You will learn a lot of them. Basically, we can upload our stuff. The embeddings models store it in the vector database, and then we can use a user query. The LLM can do this so-called function calling and can simply query or search the vector database if it's needed. If it's not needed, the LLM will simply give us the answer back. So if we ask something that is not stored in the vector database, the LLM will not do function calling. So this is function calling with the RAG technology, and you have also learned what vector databases and embeddings models are. And I see you, of course, in the next video.